In this practical example we will develop the design of a bearing, reviewing the commands learned throughout the course. Let's start by creating a new file, using the default file shown. Proceeding, we create two layers, one center in cyan color and line dash dot, and a layer of invisible line, with dashed line in red color. Now, with the line stroke command, we start tracing the contours of the part, obeying the dimensions presented. To facilitate the development of this inclined part, we use the offset command to define the thickness of the part. Still with this command, we've defined the hurricanes, see. We finish the front view of the bearing by inserting the rounding radii of the edges. Let us now create the top view of the piece. To do this, we activate the rectangle stroke command and create the rectangle that will represent the base of the bearing. Use this reference point to facilitate the placement of the rectangle. Now we insert a circumference at this point to begin the definition of the base drilling. With this first circumference inserted, we will create a copy in the rectangular pattern, with 2 rows and 2 columns, having spacing of 25 between rows and 41 between columns. Proceeding, we represent only the initial part of the bearing body, as the rest of the body will be represented with an auxiliary view. We finish the top view by inserting the rounding of 5 at the edges of the rectangle. To facilitate the application of these rounding, we use the polyline mode, C. Next, we'll draw the auxiliary view. With the active line command, we click anywhere near the inclined bearing body. With the aid of polar coordinates, we set the view of the bearing, follow. We use the offset command to define the center of the drilling of this bearing body. We must insert in this view a winding line, as the view is interrupted. To do this, we activate the command spline fit and disable the orthogonal command to make it easier to define the points of the curve. Note: we finish the design of the bearing by inserting the dimensions necessary for its manufacture. To scale these slanted elements, use the apparent intersection precision point, which will allow you to capture the intersection point of these two lines. And so we end our example, where we developed the design of a bearing using the resources learned throughout this course.